On today's menu, Saira Arshad, an advanced skills teacher in mathematics, will be serving up a great way to teach equations to Year 9. Her Key Stage 3 lesson on a plate.
Here's my recipe for teaching algebra. It's a bit different because, crucially, it begins at the end.
There are some amazing free ingredients to motivate your own class.
Come on, Year 9, get your thinking hats on.
Oh, yes, minus.
And an easy way of solving some not-so-easy maths.
I was surprised by the equations I could solve by the end of the lesson.
If you do it bit by bit, then gradually you'll get there in the end.
All the ingredients for this lesson are available on the Teachers TV website, including the video clip, handouts, and of course Saira's lesson plan. Everything you need to serve it up to your own class.
To get the lesson off to a flying start, I'm going to sprinkle a little bit of magic.
I'm more magician than mathematician, but I do know some great tricks involving the mystery of numbers. And I'm here today to impress some unsuspecting members of the public.
That is really, really good.
I am impressed. That was cool.
No! That's real. And you can judge for yourself whether it's down to my mind-reading abilities or is it just simply the magic of maths. Put them in your pocket. Yeah, sure. Olivia, I'm going to get you to take that.
Thank you.
Can you just put them in your pocket? Think of a number between 1 and 100.
1 and 100,
Yep.
okay.
And times it by 2. And plus 10, divide it by 2. And can you take away your original number? Can you show the camera so they can sit? Thank you very much. There are 4 suits in the pack of cards. There are clubs, hearts, spades, and diamonds. Think of one in your head. Go now. What was your suit?
Spades.
Spades.
Clubs.
Clubs. What was your number?
It's number 5.
What was your number?
5.
Turn it over, Fawn. Turn it over. What? Have a spade.
That's brilliant.
5.
5.
Oh, come on. See this.
I like that one.
Was he really a magician? Was he really doing all of those things, mind reading what their prediction was? Or did he have any other way of working out what they would say? What do you think?
Maybe he guessed the number and did the equation in his head.
Did the equation? Why do you think it's an equation?
Because he had to work it out beforehand because he told them to do something on the calculator.
Right, okay. Very good observation. Anybody got any other ideas or something similar, something different?
Whatever numbers they put in, the answer would always be the same.
Right, and they showed that really well on the clip, didn't they? Because they all got the answer of 5. Right, excellent. The video clip was really useful because it hooked them and it gave them an appreciation about how equations is not just something that you do in a maths lesson, but it can be used in different situations or different scenarios. So I think that was really good. Now for a game of equations mix and match. This will really set the students thinking. What I want you to do is match together the worded description to the equation written in algebra.
4 times the number is this one.
Yeah.
10 take away number gives you 3. Number is doubled and then it has 4 subtracted. This leaves 16. What is that number?
Now in pairs, work together to solve the equation. And what I'm especially interested in is different methods.
Do it trial and error. It takes a bit longer. I think the best way is to do it 16 plus 4.
Then divide it by 2 to get 10.
Yeah.
Yeah, that's an easier method.
That'd be easier.
Or add a number, gives you 7. 7. Okay, so you just minus 4 from 7. So it's
10 minus x equals 3. Take this plus 3 on this side, which makes it minus 3. 10 minus 3 equals x, and 10 minus 3, 7 equals x.
Miss, how do you work out the answer for that if it's square root?
If I said to you, what's the square root of 25? What would you say to me?
5.
5, because...
It's 5 times 5, so it's the same number.
OK, so the square root of what number then is 7? How could you work backwards?
49.
Excellent. So the value of x in that equation is?
49.
Brilliant, well done. The students are going to work backwards to build up the equations from the solutions. I'm going to model this first using an equations web. If I I start off with a solution of an equation as x equals 9. So that's the answer to my equation. Okay, what could the equation have been to start with?
X plus 10 equals 19.
Brilliant. That's one equation that we've got.
2x equals 18.
X minus 10 equals minus 1.
18 divided by x equals 2.
I hope everyone's checking and solving these equations in your head.
X divided by 3 equals 3.
Brilliant, another division one. I like that because that's different to the one we had there. Here you've got x as the numerator, there x is the denominator in that equation. Well done. Okay.
The square root of x equals 3.
X squared equals 81.
X squared equals 81. Right, all of those that we've seen so far are one-stage equations. What I want to do is to look at how we can build those up. Let's have a look at what I've written here. What's different on the left-hand side?
There's 2x squared instead of just being x squared.
If 1 lot of x squared is 81.
Is it 162?
Brilliant, well done.
Working step by step,
Okay.
Cyrus soon spins some more complex equations into her web.
We started off with an excellent one, which was x squared equals 81. We then doubled, we then subtracted 150, we divided by 3, and finally we took the square root. So if you saw that in equation on its own, you might think, how on earth am I going to solve that? But you can see how that equation has been built up. What we're going to do now is I've got a sheet like this for you to work on in pairs. Here we go.
That one's 14 divided by 7, and that's 2.
21 plus 17 is 38. The square root of 64 is 8.
The process of going backwards to solve the equation, to build the equation up, helps them to visualise the steps to create that equation and then to work backwards to solve the equation.
So x is 7, so that would be 7 minus 10.
I actually taught this lesson with a Year 7 mixed ability group. It's interesting to see the reaction to the spider diagrams where instead of looking at the family of equations and following through, starting with the simplest, then going to the next one, it's like some of the kids just waded into the hardest one. We're going to crack that first. And it is an achievement for them. Yeah, I told them to go home and write down one of the hard equations that they did, show it off at home. I can do this, Mum. So yes, there is an element of fun. It's success, isn't it? Everybody loves being successful.
Yeah, you square root it, which is 2.
It's very important to me that the pupils understand where things are coming from rather than rely on methods too much to be solving these things. I really enjoyed the lesson in that respect. I think it does show why algebra works.
And if you'd like to try your hand at teaching this lesson, Cyrus' lesson plan is available to download below for those of you watching on the Teachers TV website.
The next stage now is for you to get creative. I'm going to bring round an A3 sheet of paper with some pens, so really get your creative juices going. Your equations need to be made up of a minimum of 4 stages, and then we're going to swap them with people around the room. So try and make them really difficult.
Maybe we should do an odd number because it will be harder. Times 5 is 34 cubic, which equals 8.
The next task is for the pupils to solve each other's equations. This can prove to be quite a challenge. When they're creating an equation for someone else to solve, they want to make it as difficult as possible to raise the level of challenge for their peers, which is fantastic, which is really good. So it makes them think that little bit harder, get their creative juices going, and to think of something that someone else might not have come up with.
Thank you.
Is it 13? Yeah. Is it 8? Yeah, I got it right.
Students should now be really buzzing to solve one of these equations that they've created during the lesson.
Should we do the top one?
Yeah. Okay, 3 minutes, choose one and solve it.
So it's 64. Because we times that.
So that'd be
equals 8. And x equals 15.
For the plenary, the pupils get to play teacher.
We started with the answer, which was 9, and then we did the inverse operation of squaring, which is square root. So the square root of 9 equals 3.
I thought the lesson was really fun because normally we just do work off sheets, but we got to do more physical things and swap questions with other people. It was fun to see who could solve them and if we really understood them.
The best bit of the lesson was when we got to swap equations and then we got to work in teams to solve them because I really enjoy working in groups.
Instead of timesing 12 by 2, we divided it by 2.
I think the teachers made this lesson a lot more fun to me than it would have usually been. And I think this lesson kind of helped me a bit more with my equations because the activities will stick in my head more when it comes to tests and stuff.
Creativity is something that definitely we want to develop in mathematics. So it's really putting the onus on the pupils for them to come forward with the ideas about how they would create the equations. And I think the fast pace, the buzz, the excitement that's generated with it and the hook of the movie clip at the start lends itself to being a very good lesson.
So how could Syra's magic maths lesson be adapted and served up to other age groups?
The lesson could be adapted to all year groups and all abilities because algebra starts at level 4. You can bring it right down to level 3, level 2.
If I was to teach it to a set 1 or older groups, I'd be encouraging the use of more fractional coefficients or just fractional constants, sticking with the integer numbers for the weaker groups and the harder coefficients, fraction numbers, things like that. Maybe indices as well, using for the older groups or the more gifted groups, if you like.
Brilliant work, girls.
The equations web idea was absolutely fantastic. I mean, that could be applied to such a lower ability as well, just doing basic addition and subtraction sums, and even to middle abilities and working out percentages, and taking it all the way up to A level even, and working out calculus questions, etc. So the idea was brilliant.
It's very challenging. You have to make sure that it is accessible, mathematics, but you do want to put a degree of challenge in.
The ideas were brilliant, you know, it was a fantastic creative lesson. I think this is an absolutely definite recipe for success in our maths department.
And remember, everything you need to create this dish for your own class is available on the page associated with this programme on the Teachers TV website. Video, PowerPoint presentation, handouts, and of course, Syra's lesson plan. A true lesson on a plate. And if you'd like to find out what other teachers think about the lesson, why not join the online conversation at teachers.tv/group/lesson on a plate.